Hello, in this video I'm going to talk about a Super Mario model which was made in Embedded Montaarc. Embedded Montaarc is a domain-specific language to model and control cyber-physical systems. Let's have a look at the game. The game was initially developed by Nintendo, and we use a third-party web implementation in which we extracted the data. We modified the JavaScript code so that we get the obstacle positions, enemy positions, hole positions, and got options to control it via flags. In this case, jump, shoot, and setting the direction. Let's have a look at the visualization. The first component we see is the Super Mario wrapper. It merely gets the data out of the game, the raw data, out of the JavaScript game, and forwards it to the controller. The information we get are the height of Mario, his velocity, the next obstacle positions as a matrix, the next hole position, the next loop trade position, Mario's position, and the next enemy's positions. And as output ports, we have the instructions if you should crouch, like Mario down, if you should shoot, Mario shoot, the direction we want to go in, and a flag which indicates if we would jump or not. Let's have a look into the controller. The controller itself consists of 3 units: an obstacle controller, an enemy controller, and a component which just takes the binary OR relation of those two to decide what to do. Let's have a look into the enemy controller first. Here you can see that the enemy's data is extracted via enemy factories, which get the raw matrix with all the data and turn it into an enemy's object, which in turn is provided to a strategy component. The enemy component itself is rather simple. It just consists of an X position, or X distance, Y distance, and a velocity. Here you can see that the enemy component itself calls another subcomponent which computes the velocity. Now, as the enemies are forwarded into the strategy, the strategy consists of several enemy watchers, instances which are there to watch the specific enemies on where they are, on their velocity, and decide if it's in jump range, if it's moving towards the player or not. And the basic idea of this simple strategy is if any of those enemies gets into range to being able to jump over, we just jump by again connecting every output with an OR. So the enemy strategy returns the jump advice if any one of those enemies is close enough. This again is forwarded out of the enemy controller into our overall controller. The same basically goes for the obstacle controller, with the mere difference that it doesn't use a velocity to determine if we should jump or not. But on the basic idea is the same. In terms of code, this is the wrapper which just forwards the data into our controller. The controller itself splits up the two tasks of looking at the enemies and the obstacles. And the actual enemy and obstacle controller again forwarded to the data to the factories and to the strategy we've seen in the overview earlier. The strategy itself consists of the enemy watches, which are instantiated and connected 5 times, and then are ored together to get the final decision to jump or not. This all gets handed back into the Super Mario wrapper, which in turn gets the information back into the simulator, which presses the button for Mario. As of now, holes aren't detected. That's why we are falling inside of the map and ultimately fail the level.